Welcome to my second video on the integral calculus. Today we are going to cover the method of u-substitution. I know in some textbook and like in some school, we kind of set this one in the later on chapters for like integral calculus, especially when we talk about definite calculus. Definite integral. That's sometimes that's when u-substitution pops out, and I kind of find this ridiculous a little bit, especially after we talk about the technical guessing in the previous video in definite integral. And so today, I'm just I think the topic is very important for us to later on to solve it. But now let's get an idea of what u-substitution is, and let's jump in. Okay, so basically, when we were asked to integrate a certain function, they always look kind of in this form. Okay, so if you look back my previous videos about guessing, when I talk about guessing, or when you look on my problem, then I post it on my description on my previous video, you will see that I kind of like using this kind of form to like ask you to do the guessing. Okay, so for u-substitution, instead of we guessing it, we can substitute u into a certain function. But again, because of the name called u-substitution, we use the u. But in theory, you can use any variable you want. You can use a, you can use b, you can use c, right? Because we kind of respect your name, so that's why we want to use u. Okay. So now we use u-substitution. Now we have like we set u is equal to g of x, right? And so if I differentiate u in terms of x, so that means I'm differentiate the function of g of x. And so that would mean du is equal to g of, so differentiate g of x times dx. So what I realize is I can see that this part here, I can write du. This g of x, I can rewrite as like u. So I'm going to rewriting this again, kind of like rewriting the question again. I don't know why. I'm sorry if you don't like it. So yeah, so I can see that I can do this, right? Because again, I see this one is du and I can say this one is u. All right. So now I want to assuming that, if I have the function big F of x and I differentiate the big F and I got a small f of x, right? So here, what I want to do, sorry, I think scroll up too much. So all I want to do is, so after when I integrating the big F into respect of u, then I got a small f, integrate the small f into respect of u, then I got a big F and u inside plus c. Am I finished yet? The answer is no. I have to substitute the u back to g of x. That's the general idea of u-substitution. You got the idea, good, you're good to go. Okay. Now I'm going to introduce you the first problem, but my first problem is exactly the problem when I started introducing guessing on the previous video. So what I did is I kind of introduced this function, and I asked you to guess what is the result is. Okay, but instead of using the word guessing, we can use the u-substitution. Now, why I think we can use the u-substitution? First, it just followed the flow of like, g of, it's just following the flow of this function, right? So for anyone who can say which one is f of x and g of x, like, congratulations, you're an A plus student in the integral calculus. Okay, right. So if you don't see it, don't worry. My suggestion is that look for the one that looks the most complicated and go for it. Substitute this at u. So what I mean by that is, can put out f of x is equal to square root of x, right? and g of x is equal to x plus 1. Now, if you don't see it, later on I will tell you how you can do it. But now, for anyone who's because for this introduction to u-substitution, I want to follow exactly the same flow as I introduced in this part. Okay, so right now, so as I introduced, I said u is equal to g of x, right? And that's equal to x plus 1. So I got du over dx is equal to g of the differentiate of g of x, that means the differentiate x plus 1, that means equal to 1. So that means if I'm rewriting this, I got like, u1 times dx. So du is equal to d of x. So what I found is that I can rewrite dx as du because of this, du is equal to dx. The second part is I can write x plus 1 is u, right? So by rewriting this again, I can write it as u du, right? So now, I can rewrite it again in this form so that we can see clearly what we have to do. Okay, now using the formula I introduced in previous video. So we got like 1 over 2 plus 1 times u to the power of 1 over 2 plus 1, right? Plus c. That is equal to 2 power of 3 times u to the power of 3 over 2 plus c. And yeah, am I done? Not yet. Substitute the u back. X plus 1 to x plus 1 to the power of 3 over 2 plus c. And this is my answer, and it's exactly the same answer as the guessing video and the previous video when I talk about guessing again. Yeah, that's a great news, right? And you can use either guessing method or use substitution whenever you see this kind of like technique. So to sum up again from today's video, if you kind of spot everything in this form, right, we can use substitution by setting u as g of x. Sometimes it's not obvious in this format, or sometimes it's not in like obvious. So what I mean is that what if I ask you to different integral this function, right? How can you do this? So remember previous on the previous problem when I talk about you cannot spot g of x. Look for the function that has the most complicated one. That is the most complicated one. So well, now I know we can see is that there are three elements in there. It's 1x and natural log of x, right? And think about differentiation as well. So if I differentiate 1, what's that equal to? Differentiate 1 is equal to what? X. Sorry, 0. Sorry, I think what interval. Differentiate 1 is equal to 0. Is that useful? Nah. If I differentiate x and I get 1, is that useful? Well, if I set u is equal to x, okay, and if I differentiating this, got 1, what about my natural log of x? It doesn't help at all. So that means if I cannot put u is equal to x, the only one left is u is equal to natural log of x, right? And that's what I mean by looking for the most complicated one. So because in this two, this one is look like more intimidating. So what happened is what I want to do is that I'm gonna set d over dx time is sorry, we kind of differentiate natural log of x, so that means equal to 1 over x, right? That's exactly what I said when I talk about indefinite integral. And so w du is equal to 1 over x times dx. Okay, now if I'm rewriting this, I'm rewriting this part again. Sorry, that's my kind of habit to do math, is rewriting the question again. So yeah, so if I'm rewriting it in this form, I can see clearly that I can be writing this as u. This part, sorry, this part as du, this part as u. the natural log of x is u. The whole part there is du. Okay, so now based on that, I can rewrite everything again. So integral of 1 over u times du, right? Would that be equal to what? So integrating of u to the power of -1 du. So again, u to the power of -1 du is equal to what? Natural log of the absolute value of u plus c. Okay, and so am I finished yet? No, I'm not. I have to, substitute the u to natural log of x. Always remember the absolute value plus c. Looks complicated, but if you can't see my answer, recommend you to like solve it by yourself, and you see, you can see it yourself. Trust me. Now, right. So now to sum up to this point, again, if it in the form of f of x, g of x, we put u is equal to g of x, right? If it's not in any of the form, what we only do is we find the one that's we tend to find the one that's look most complicated. We set it as u and we solve it. If not, if this not working, it's like what I did is that I change to another element, and I just do the u substitution again. Hope it works, right? I hope this kind of a suggestion or a recommendation idea kind of works. Sometimes when we're doing this kind of u substitution, it's just not obvious when we get the right answer or not. So it's just sometimes, okay? For example, this one, I know for sure this is the only right answer, so there's no other answer, or because we cannot set u as any other element. Any other element, I'm not sure that's the right word for that, but again, if I ask you, then it's all, by the way, this sometimes we all see this a lot in the trigonometry. So if I ask you to integrate this one, all right, so how are we going to solve this one? Now, if you are a fan of sine of x, so let's put u is equal to sine of x, okay? So if you like sine of x, we put u as equal to sine of x, shall we? So now if I differentiate du over dx, okay, so that means I'm differentiating sine of x is equal to cosine of x. That means du is equal to cosine of x times dx, right? So that means I'm realizing that this part I can set as a du, sine of x I can set as a u. So I'm rewriting this again, and then I write this one in terms of u substitution, in terms of u, and so gonna differentiate it. Sorry, integral this. So that'd be u to the power 1 plus 1 plus c. It's equal 1 over 2 u to the power of 2 plus c. Am I done yet? Not yet. 1 over 2 times u, I said it's at x plus c. Okay, same problem, but this time I set it in cosine of x. Okay, now if I differentiate u in terms of x, for cosine of x, I get is a negative sine of x, right? Now, du is equal to negative sine of x dx. Okay. Right. So what happened here? I'm going to be writing this again, but because this one I'm not going to apologizing for rewriting this because it's kind of important for us to see. Well, now I see my du value is negative because of this sign, but the expression over here is positive. So if I have to introduce u substitution, I'm going to be rewriting this. Okay, I'm going to be rewriting this part. Okay, for you to see clearly. If I have to introduce u substitution, this du here, I can write this as du, but remember this du here is negative. So I have to balance this off. So this part is u, right? So what do I mean by balance? It's off is that I have to introduce a negative sign, right? Because my du is negative. I have to put a negative sign so that negative and negative can cancel out. And so I can get to this one. Okay, so integral of u du, but I have to remember put a negative sign in front of it. Right, so same thing, gonna be negative 1 over 1 plus 1 u to the power of 1 plus 1 plus c. Well, I only have to do is actually calculate it, and I got this one. Okay, am I finished yet? Not yet. So it's equal to cosine of x squared plus c. Right, right. So the first problem, I got this answer. The second problem, sorry, this is the second problem. They're the same problem. The first one, I said use a dx, and I got this one answer. And the second one, I said use a cosine of x, and I got this answer. Right. So sometimes it has more than one answer based on which one you're setting as u. So is both of them are correct. So both of them are equal. What other people call it? Both of them are kind of relating to function or in one part of the family of the function. So again, so if you look at the trigonometry again, so you can see two of them are kind of equal. I just don't know how to explain this, but if you know, leave in a comment, let me know how to explain this. I kind of used in the way of subtracting these two together. So what I do is that I'm kind of doing this, right? So I'm kind of subtracting them together, but it just, I don't know how to interpret it correctly. So what I have is like this. Okay, this is only my problem. I just don't know how to explain it. So what I want to prove is that, sorry, this one should be 1 over 2 sine to the power x plus c, this one plus c, right? So what I want to prove is that I kind of want to subtract both of them so that what I hope is getting 0. Okay, but when I do that, it's negative, negative become positive. It's become adding two of them. And then what I got is finally it's not 0, it's 1 over 2. I know this one is like is equal to a constant. I don't know how to explain this one that to make them equal. If you do know, please leave it in comment and I would love to know. But again, the method of u-substitution, sometimes it's kind of tricky is that it's get more than one answer, but don't panic. Sometimes your answer is also the good answer. Unlike, but this sometimes we usually say it in trigonometry. But for the previous part, when it's not involved with tricks, I believe that it's leaving only one answer. So it's only one u-substitution you can do. And this is the again a basic idea of what u-substitution is. Yeah, kind of finished my video on u-substitution. Thank you so much for watching. I hope to see you in the next one.